The Y-delta reduced start, also called star-delta, is intended for use with Y-delta motors where the motor is started in a Y configuration and then switched to a delta configuration. As you can recall, three-phase motors are available in Y or delta configurations. These windings are internally connected, and the T1, T2, and T3 terminal wires are brought out of the motor for connection to the motor starter. The Y-delta motor has 6 leads, T1 through T6, brought out of the motor. No internal connections are made from the factory, thus allowing the electrician or technician to wire the motor in a Y configuration or a delta configuration. For example, in a delta configuration of a 208 volts motor, terminals T1 and T6, T2 and T4, and T3 and T5 are connected together to form the delta connection. The voltage between each phase is the 208. When the motor is connected as a Y, having terminals T4, T5, and T6 tied together, the voltage between the phases before the motor will be 208 volts. However, the voltage across each winding to the neutral in the motor will be 208 volts divided by 1.73 or 120 volts. The current and the torque in this Y-connected motor will be reduced to 33% of inrush current and 33% of normal torque, respectively. Remember that in a Y system, the line voltage is equal to the phase voltage times 1.73, while both the line and phase currents are equal. Conversely, in a delta system, both the line and phase voltages are the same, while the line current is equal to the phase current times 1.73. By switching between the Y and delta configurations in this motor, we can therefore control the reduced start voltage, thus also reducing the inrush current. This is simply done by interlocking the power circuit with additional contactors. The control circuit follows the same principle as the other reduced starts. When the start push button is pressed, the timer is energized and the M1 starter is also energized. The starting contactor S1 makes the connection through its own power contacts S1 and starts the motor in a Y configuration. Once the time delay elapses, contactor M2 closes and the motor is configured as a delta motor, thus having full voltage across its coils. The open transition occurs when the timer contacts are starting to disconnect the S1 contactor and the M2 circuit is not yet connecting the power circuit. The auxiliary contacts S1 keep this connection from happening. This very short delay is necessary to avoid a short circuit in the power system between L1, L2, and L3. The timer delay is usually set at around 10 seconds between the Y start and the delta transition. There is also a closed transition Y delta configuration, which is available at an additional cost. These closed transitions include additional contactors and a resistor bank used for the implementation of the circuit. In this configuration, the contactor S2 is used to connect the motor in a delta configuration with a resistor in series with the T4, T5, and T6 terminals. This occurs as soon as the S2 contactor closes, right after the time delay and just before the S1 contactor is de-energized, thus not allowing a break in the transition. The resistors prevent the potential short circuit. Right after the S2 contacts close, the M2 contacts shunt the resistor circuit and connect the circuit in the delta configuration, taking out the resistors by de-energizing S2. The result is a starting reduced current of 33% of inrush and a smooth transition to full speed.